So the equation of a circle whose center is the origin and the radius r is x square plus y square is equal to r square. This is an example. Center and radius is given. So what is required to find is the equation of a circle. But here equation of a circle is given. What is required to find is the center and radius. Suppose if a point P lies inside the circle, outside the circle or on the circle, what is the condition? So the point which lies point inside, outside, on the circle. Suppose let us consider a point P. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very important chapter, that is conic sections. So in conic sections, we are going to study regarding two curves, that is circles, parabola, ellipse and hyperbola. So these are the four curves which we are going to study. Now, before going to the exact contents, let us know the weightage for this chapter. So you are going to get 11 marks from this chapter. So you will get 11 marks from this chapter for that is from circles as well as from parabola, then ellipse and hyperbola. So you will expect one derivation for 6 marks from hyperbola. Now, so today in this session I am going to discuss regarding what is a conic section and the problems based on the circles, right? First conic, that is circles. Based on that we are going to take the problem. So today I am going to discuss regarding the definition of a conic section and different types of conics and the problems based on circles, right? Now let us know regarding what is a conic. So here you might have been observed, here is a cone and a plane. So the section which lies between a plane and a cone is called as a conic section, right? So if you take the intersection of a plane, so the intersection of a plane with a conic, then that is called as, then that section is called as the conic section. So the intersection of a plane with a cone is called as the conic section. The curves obtained by intersecting a right circular cone with the plane is called as the conic section. That is called as a conic section. Now, the intersection of the plane with the cone may take about the vertex or at the vertex or above or below the nap. Now, depending on that, when the plane cuts a nap of the cone, when we have the following situation. So, when the plane cuts a nap, depending upon the following situation, we are going to get the different curves. So that is different conics. So when beta is equal to 90 degrees, then the section is called a circle. See, when this beta is equal to 90 degrees, then the conic is called as a circle. Then it is a circle. Similarly, when beta lies between alpha and 90, that is, if beta is in between alpha and 90 degrees, then the cone is called, then the section is called as an ellipse. Yes, if beta is in between, this beta is in between alpha and 90 degrees, then it is called an ellipse. Similarly, if beta is equal to alpha, then the section is called as a parabola. If beta and alpha are equal, then it is called as a parabola. And finally, if beta is in between 0 less than or equal to beta less than alpha, then the section is called an hyperbola. So this is a hyperbola. Depending upon the following condition, that is when beta is equal to 90 degrees, then the section is called as a circle. If beta is in between 0 and 90 degrees, then the section is called an ellipse. Beta is equal to alpha, then the section is a parabola. If 0 less than or equal to beta less than alpha, then the section we are going to get is called an hyperbola. So this is circle, ellipse, parabola and a hyperbola depending upon the value of beta, right? Now, let us know regarding the first one, circle. What is a circle? Now, let us move on to the first concept, that is the circle. So, for a circle, when beta is equal to 90 degree, then the section is called a circle. So, what is a circle? A circle is a set of all points in a plane such that it is equidistant from a fixed point in the plane. So that means a circle is a locus of a point which moves in a plane so that its distance from the fixed point to the origin is constant. That constant distance is called the radius. So the fixed point is called the center and the constant distance is called as the radius of a circle. So a circle is a set of all points in a plane such that it is equidistant from a fixed point in the plane. Suppose if I draw, this is a circle, right? So this is a fixed point, this is a fixed point, and this is the center. So the distance from O to P is a constant, and this distance is called the radius. OP is equal to R is called the radius is a constant distance. So the fixed point is called as the center of the circle, and the distance from the center is called as the radius of the circle. Right. Now the equation of a circle having the center, having the point P x comma y, you might have been studied equation of a circle with point x comma y and the center 0 comma 0 as the origin is given by the equation of the circle is x square plus y square is equal to r square is the equation of the circle. So x square plus y square is equal to r square is the equation of a circle whenever the center is 0 comma 0. For example, let us take an example. Find the equation of a circle whose center is 0 comma 0 and the radius is equal to 4 centimeter is x square plus y square is equal to 4 square. That is nothing but x square plus y square is equal to 16 is the equation of the circle. So the equation of a circle whose center is the origin and the radius r is x square plus y square is equal to r square. This is an example. Suppose if the center is changes from h comma k. Now let us consider. So the general equation of a circle where suppose this is the circle, x-axis, y-axis. If the center is h comma k, this is the center, and p x comma y be any point on the circle, r is the radius. So this is origin. So if h comma k is the center of the circle, then the equation of a circle is given by x minus h whole square plus y minus k whole square is equal to r square, where h comma k is the center and r is the radius. Very simple. If you apply the distance formula, you will get x minus h whole square plus y minus k whole square is equal to r square, because here Cp is equal to r. So squaring on both sides, what happens? Cp square is equal to r square. So if you apply the distance formula for this, you will get x minus h whole square plus y minus k whole square is equal to r square. That's it. So therefore the equation of the circle in the standard form is x minus h whole square plus y minus k whole square is equal to r square, where r is the radius and h comma k is the center. Let us take for example, if h comma k, the center is equal to 1 comma 2 and radius is equal to 3, then the equation of the circle is x minus 1 whole square plus y minus 2 whole square is equal to 3 square. So if you apply a minus b whole square formula, then you will get a square plus b square minus 2ab, x square plus 1 minus 2x. Again it is y square plus 2 square minus 2 square, that is 4, a square plus b square minus 2ab, 2 2s are 4y, minus 9 is equal to 0. Put it in order. X square plus y square minus 2x minus 4y, 4 plus 1 is 5 minus 9, 5 minus 9 is minus 4 is equal to 0 is the equation of the circle. So if h comma k is the center and r is the radius, then the equation of the circle is in the form x minus h whole square plus y minus k whole square is equal to r square. Important for 1 mark. You may expect 1 mark from this. Now let us, by knowing this, let us take few problems. Find the equation of a circle with center minus 2 comma 3 and the radius is 4. Now what is given here? Given center h comma k is equal to minus 2 comma 3 and the radius is equal to 4. Now equation of the circle is x minus h whole square plus y minus k whole square is equal to r square. Now x minus, what is h? Minus into minus plus 2 whole square plus y minus k, what is k? 3 whole square is equal to r. R is 4 square, right? X plus 2 whole square plus y minus 3 whole square is equal to 4 square. Now apply a plus b whole square. A square plus b square, 2 square is 4 plus 2ab, 2 2s are 4x. Again a minus b whole square. A square plus b square, 3 square is 9 minus 2ab, 3 2s are 6y, and 4 square is 16. Bring that 16 to the left hand side, it becomes minus 16. Now put it in order. X square plus y square plus 4x minus 6y, then 4, yes, 9 plus 4 is 13, 13 minus 16 is minus 3 is equal to 0 is the required equation of the circle. X square plus y square plus 4x minus 6y minus 3 is equal to 0 is the required equation. Right. Hope you followed. Okay. Now move on to the next problem. Find the equation of a circle whose center is 1, 1 and radius is 2. So here what is given? H, k 1, 1 and the radius r is equal to root 2. So equation of the circle is x minus h whole square plus y minus k whole square is equal to r square. So x minus h is minus 1 whole square plus y minus k 1 square is equal to root 2 whole square. Now simplify this. If you simplify, so if it is for 1 mark, you can stop here itself. If it is for 2 marks, simplify this. Now this is a square plus b square minus 2ab, a square plus b square minus 2ab is equal to square root gets cancelled. So this is x square plus y square minus 2x minus 2y, 1 plus 1 is 2 and bring this minus 2, plus 2 to the left hand side becomes minus 2 plus 2 gets cancelled. So therefore the required equation is x square plus y square minus 2x minus 2y is equal to 0 for 2 marks. So if it is 1 mark, you can stop here itself. For 2 marks, just simplify it. Okay. Now move on to the next problem. So find the center and radius of the circle. So this is as that of the previous problem, but in previous problem, center and radius is given. So what is required to find is the equation of a circle. But here, equation of a circle is given. What is required to find is the center and radius. Now, just observe carefully. X square plus y square plus 8x plus 10y minus 8 is equal to 0 is in the standard form. So comparing with, so the standard form of this equation is comparing with x square plus y square plus 2gx plus 2fy plus c is equal to 0. Comparing with standard equation x square plus y square plus 2gx plus 2fy plus c is equal to 0. The center, here the center c is equal to minus g comma minus f and the radius r is equal to root of g square plus f square minus c. Now comparing with the standard equation, the coefficient of x is 2g. So 2g is equal to 8, g is equal to 8 by 2 is 4, 2g. Again 2f is the coefficient of y, 2f is equal to 10, f is equal to 10 by 2 that is equal to 5 and c, constant c is equal to minus 8. Substitute here, therefore the center c is equal to minus g means minus 4 comma minus f is minus 5. This is the center. Center c is equal to minus 4 minus 5 and the radius r is equal to root of g square. What is g? 4 square plus f square. What is f? 5 square. G square plus f square minus c. What is c? C is equal to minus 8. Now this is equal to root of 16 plus 25 minus into minus plus 8 is equal to square root of, yes, what is this equal to? So 16 plus 8, that's equal to 24 plus 25. 24 plus 25 is equal to root of 49. Square of 49 is 7. So therefore the radius of the circle r is equal to 7. Center is minus 4 comma minus 5 and the radius is equal to 7. That's it. Very important for 2 marks, right? Hope you followed. Okay. Now move on to the next problem. Find the center and radius of the circle x plus 5 whole square plus y minus 3 whole square is equal to 36. Now just this can be written as, the given equation is x plus 5 whole square plus y minus 3 whole square is equal to 36. This can be written as x plus 5 can be written as minus of minus 5 whole square plus this is as it is y minus 3 whole square is equal to 6 square. Now comparing with, if you comparing with x minus h whole square plus y minus k whole square is equal to r square. What is h? H is equal to minus 5 and k is equal to 3. R square is equal to 36. So therefore r is equal to 6. So therefore the center, what is the center? Center c is equal to h comma k, h is equal to minus 5 and k is equal to 3, and the radius r is equal to 6. So the center is minus 5 comma 3, the center is equal to minus 5 comma 3, and the radius is equal to 6 is the required answer. That's it. Hope you followed. Okay. Find the equation of a circle passing through the 2 points and whose center lies on the line. So the equation of the circle, the required equation of circle is of the form x minus h whole square plus y minus k whole square is equal to r square. Let us represent this as equation number 1. Now what is given? Since it passes through, so it passes through what are the points? 2 comma minus 2 and 3 comma 4. So therefore the required equations are x, this is h comma k, again this is h comma k, you will get x minus 2 whole square plus y minus into minus plus y plus 2 whole square is equal to r square. Let us represent this as equation number 2. And similarly for this another point 3 comma 4, so the equation becomes x minus 3 whole square plus y minus 4 whole square is equal to r square, equation number 3. And further, what is the given condition? So whose center lies on the line. So the center h comma k lies on x plus y is equal to 2. So therefore h plus k is equal to 2. Let us represent this as equation number 4. Now if you solve equation 2, 3 and 4, so what is the value of h? So by solving 2, 3 and 4, you will get h, k and r values, right? So on solving this, we will get h is equal to 0.7, k is equal to 1.3 and r square is equal to 12.58. Simplify this, you will get hk. So therefore equation 1 becomes the equation of the circle is x minus h, which is 0.7 whole square plus y minus k is 1.3 whole square is equal to r square is 12.58. This is the required equation of the circle. That's it. Okay. Suppose if a point P lies inside the circle, outside the circle or on the circle, what is the condition? So the point which lies inside, outside, on the circle. Suppose let us consider a point P. Px comma y be any point. Suppose if P is inside the circle, if this point P is inside the circle, then the distance Cp is less than the radius. If the distance from Cp is less than the radius, then the point will lie inside the circle. Suppose if P is on the circle, means the distance from C to P, that is the radius, is always equal. So if Cp is equal to the radius, if the radius and the distance from Cp are nothing but same, then the point will lie on the circle. Suppose if P is outside the circle, if point P lies outside the circle, then the distance C to P is greater than the radius. So if the point P lies inside the circle, means Cp is less than the radius. If the point Cp lies on the circle, means C to P distance is nothing but the radius. So here Cp, the Cp is less than radius. Here in this case Cp is equal to radius. If point P lies inside the circle, means the distance Cp is less than the radius. If Cp and the radius are same, then the point lies on the circle. If the distance from C to P is greater than the radius, then the point lies outside the circle. So hence the distance C to P is given by the distance Cp is equal to root of h minus x whole square plus y minus k whole square, or x minus h whole square plus y minus k whole square, where r is the radius of the circle. So hence in general the equation of a circle x square plus y square plus 2gx plus 2fy is equal to 0. The center is equal to minus g comma minus f, and the radius is equal to root of g square plus f square minus c. So the same equation can also be written as x minus h whole square plus y minus k whole square is equal to r square. Here the center center is equal to h comma k, and the radius is equal to r. These two types of formulas are very important for solving the problem. So far we have discussed the problems regarding these two types. That's it. These are the things which we are going to study in circles. That's it. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.